Hey everybody, um, my name is Dag, and let's go cloud. So today we're just going to be talking about building a serverless app using Go. A little bit about me, I'm from Capital One. I work on like credit offers team, so if you've ever seen any of the credit cards online on like Credit Sesame, Credit Karma, NerdWallet, so my team manages that. We manage pre-qualifications. If you've ever been pre-qualified for a Capital One card, so that's kind of like what we work on, and we're going serverless. So I'll just talk about some of that stuff. A little bit more about me. I graduated from Virginia Tech. I got actually introduced to Capital One through a hackathon using their APIs, and that's how I ended up working there. I play tennis, I make synth music, and I'm on PS4. PS4 fam, not Xphone, but yeah, pretty chill. But cool. Okay. So I'll just go through like an agenda of what we're going through today. I'm gonna start off giving you like an overview of what it means to like build a serverless application and like what that is exactly. And then we'll go into like the basics of like building Go with serverless, the advantages that you get out of building like a Golang application for serverless, and like the pros and cons of that, and when to decide when that's right for you. When is serverless useful? If you have a large application, it might not be useful. We'll go into like what actually makes serverless like really useful for some people and might not work for all applications, but it has like a lot of benefits along with it. And then I'll do a live demo. For the demo, for the purposes of like teaching you serverless with Go and just like the fundamentals of it, I will be using Amazon Web Services just because right now Google Cloud doesn't natively support Go, which is slightly ironic, but you can build a Lambda function the exact, like almost the same way that you would build a cloud function. Just in Go instead of Node. But I'm sure the support will come soon. There's like unofficial wrappers, but otherwise, yeah, it's still possible if you go that route. And yeah, feel free to interrupt me if you have any questions while I go through this. But cool. So I just wanted to give you like a little background on the transformation of the development process, like as a software engineer, like how we got to serverless in the first place. And this is something that we're doing at Capital One and like transforming like really quickly. Traditionally, we had like DevOps, and now we're moving like closer to NoOps. Beyond that, breaking down the wall between like what it means to be a developer and what it means to do operations, and that's kind of like becoming more blurred nowadays. We don't have like as many dedicated teams for operations. Those skills are acquired by our developers, and that's what we're trying to do. We're trying to build people that are well-rounded and like also have tools that let you make that easier for you. This incentivizes like people, developers, to like build low-maintenance systems because that on like the same side will give them more opportunity to develop. And actually, it's like operations is definitely something that a developer doesn't really want to spend time on. And so that is just like an inspiration to make less complicated, low maintenance like apps, monolithic apps. And so that goes into like how we've transformed the application base. Like traditionally we have server-based apps. Since then we like run apps in virtual bases. And now, like most apps you see nowadays are running containers, like Docker containers, and so that's just like how like we've packaged differently, just because we want to like minimize how much operations that we're doing. And yeah, same way like we have like monolithic applications that are like service-oriented architecture. That way, like you have an application, it's broken down so it has like one function which talks to another like microservice that has one other singular function. And that is just a way that we've like decomplicated things, and that's like kind of like what serverless also will help you to do. And yeah, shrinking deployment units, it reduces like your code complexity, and yeah, it just like separates your functionality. and yeah, increases options for scalability. One drawback might just be like the complexity between communicating with these microservices that you're building, because you're separating out your application. And that's something that you just have to pay a lot of attention to once like you get into the process, especially when you're doing migrations instead of building a serverless application from scratch. It does build these complexities that you didn't have before, so you have to pay a lot of attention to that kind of thing. So yeah, so serverless and like 4 basic concepts means like you don't have any provisioning, you don't have to like worry about like servers, like AMI rehydrations, like you don't have to worry about things like that are handled for you. It's the same between like any kind of cloud functions, whether you have Lambdas or you have Google Cloud Functions. Usage scaling, everything scales on its own. It's based on like usage. So instead of having like a server with a set amount of memory, you have to like scale that memory. You have to set up auto scaling. You have to watch it, set up your alerts and everything like that. All of that usage scaling is done on the back end, and you don't have to worry about it. That's just like a very basic operational thing that people worry about a lot. That just dissipates with serverless technology. No idle costs, so if you're not using your app, it's not running, you're not paying for it. And that's a basic concept of serverless. So the idea is that your app goes up only when it's called, and so at any other time it's not running, you're not paying for it, there's no server hosting it, and it runs like on top of a dedicated server that gives it like some kind of virtual memory for the amount of time that it lasts to complete a single operation. And that function can be called as many times as needed in a set amount of time for like someone pinging your application, and then it goes back down. And so on top of that, you have like a lot of fault tolerance. Functions that are serverless are built to retry. They kind of protect themselves from failing. They have like asynchronous logging, which is another amazing thing that actually happens, but it doesn't cost you any application performance. And so yeah, you have availability and fault tolerance like built into these applications. So yeah, why build a serverless application? So building a serverless application, like it lets developers focus on application code. So like as we said before, you have all these operational things that you have to worry about, and that kind of disappears. Gives you more time as a developer to actually write more code and actually like make more functionality instead of worrying about when your app is going to go down or what you have to protect it against. Yeah, you just kind of rid yourself of like that kind of infrastructure worry. You don't have to worry about provisioning. And so the management burden is kind of eliminated, and then your application can get like to market faster. You can develop like more features, and you just have like other things that you can concentrate on, which really helps. And so yeah, and so just like from the beginning of our serverless journey, just a few months ago, we just like figured out some kind of like best practices, switching our application. So you want to think microservice. You don't want to build a serverless application like in all like one Lambda function. You want to create a network of like, you want a function to do one thing, and then if something else has to happen after, you can sequence these functions together, and then that way they're all managed on their own. And that way, if you have a function that fails and has to do a retry, it can do that one part of like your process without having to redo your entire flow. And so that's like a really interesting thing that you can do that just like breaks down your application. Yeah, figure out like what triggers your Lambdas. You have to really log like what's talking to what, and kind of like the whole networking is probably like the biggest part of it. Yeah, and so yeah, separate your Lambda handlers, which is when you write like functions or like cloud functions or Lambdas, you have handler methods that control when operations are executed, but you can actually write functions outside of your handler, like your core logic, to actually separate like just as you would with like any other MVC model or anything. You can build things outside of that basic handler and then control when things are happening. This helps a lot with cold start, which is one of the leading performance barriers with serverless. When a Lambda comes up for the first time, when that function is run without like any previous run of the application, that's when you have the most uptime or the time that it takes to get it running, and that's a cold start. And so if you separate your logic, it just helps the Lambda performs better. Use environment variables. You want to modify operational behavior. You can actually use environment variables throughout Lambdas and communicate and send variables between different different Lambdas that are doing different functions for you. Yeah, size your functions correctly. You want to keep them simple, but not too simple. That's one problem that we had. We had a lot of separated Lambdas that actually we ended up having to go back and bring these functions that we separate into this giant architecture to talk to each other together, because we were repeating a lot of code just to separate these functionalities that did very simple things that were slightly different. And we figured out that we can create models and then create smaller architectures that weren't too big. So you have to figure out your sizing. It might be easier if you're doing a new serverless application from scratch compared to a migration, which is what we were going through. So we had to take old logic and separate it. So just think about how you're networking your application, and what needs to be done in one package compared to what can be separated. Yeah, design your serverless pipeline to be ready for version deployment. You want to do canary or linear. You want to look into what's better for your application based on the size of your application, the functionality. If, for instance, an example with Capital One, we do pre-qualifications. A canary deployment might be very different from a linear deployment if we're in the process of sending someone's information to TransUnion through Axiom, and we have to figure out a way to handle that information. If an error falls and a Lambda has to do a retry, we don't want to say that they weren't pre-qualified because we couldn't make a request through. So that could happen if you're doing canary deployment and your new version is malfunctioning, and it rolls back. But if you're doing canary, you might lose less data and less information than a linear path, or vice versa based on your application. So that's something that you want to take in control and just figure out what's best for you. And so this is some notes on building Lambdas. These are just small functions. They're the same as Cloud functions. Cloud functions are only written in Node right now. But if you look into Amazon Web Services, you can write them in Node, Python, Go, Java. So it has a lot of different ways, but they're all packaged the same way. You write a handler method that controls everything, and from there you can create a whole architecture inside a single Lambda if you needed to. So a lot of things you want to you have to pay attention to a lot of different things than a normal application. There's function duration limitations, for instance, which is another reason why you want to break down your applications, because at least I know for Amazon's Lambda functions, max runtime is 5 minutes. And so if you want to build a serverless application and you have a long-running process in parts of your application, that's something that wouldn't work in a Lambda function or a Cloud function, because they're not meant to be running for so long. And so that's something you want to take apart take apart your application if you can break down that process into separate Lambdas. Control your retries. I think at first we didn't really understand that the process of retries is pretty much automatic, but you can time it differently. You can control your timings for when you want to do retries. Maybe you have one service that you're hitting outside of your application that occasionally has a low or a high response time, and so you might want that retry length to wait longer than other processes. Yeah, know your limits. Generally, the Lambda processing, you can limit the memory, like any serverless function, you can limit the memory that is assigned to it when it starts running. So when we first started running like serverless functions, I think we were giving them like 120 megabytes of memory when they came up, and we were seeing like lower response times for our application than our Go API, and so we're like, why are we like switching to serverless if it's slower? And we just had to figure out like memory management of when the lambdas were coming up, and so when we switched like 500 megabytes for a Lambda, even though it doesn't use all that memory, the processing, just like the performance, was like much faster, and it was like percentages of what our process would take for our API. So you have to know like what you're running in your Lambda functions, and like actually just provision it in different ways. CloudWatch, specific to Amazon, but it has like asynchronous logging, so you could be calling like other logging tools like logging APIs and libraries, but Cloud Functions, they're built the same way. They have a logging system that just pulls in everything like standard out, standard error. So as long as you're putting into those things, then you can like get these logs without any like processing power, and it doesn't like hit your API at all, or like it doesn't hit your application for performance, and so that's like a really great thing that you can take control of, and then from there you can export those logs to Datadog or Splunk or anything you need after that. Yeah, protect your lambdas. Give them like IAM roles or like any kind of role provisioning, and plan for dependencies. So that's like what I mentioned before. You might have like one service that you're hitting outside your application that just takes longer than everything else. So plan to spend more time on that dependency. You might even write a separate Lambda just to hit that one service and get that response, and then send it onto like your network of functions. Test everything. A lot of our learnings went through like just like a lot of testing. There's a lot of tools to test now more than before at the beginning of serverless. There's a tool actually called serverless that can help you bring up a pipeline and test locally through it. A lot of testing can just be run through like running your application. Yeah. Yeah. Yeah, I think it's definitely a tool that is like easier than setting up like Terraform. If you have like a large application, that might be an option. But otherwise, I think, yeah, serverless would be a better tool. That like the utilities that come with it, preloaded, like a lot of stuff here, can help you a lot more than setting up like Terraform, I think. Yeah, not that I've like compared them strictly, but yeah, yeah. So this is just like I want to show you, yeah, what I mentioned before, like CloudWatch logs. A lot of times that you run your application, you're like logging. Hopefully, you're logging everything you're doing. But the way CloudWatch works for Lambda functions is it just like grabs everything that you're printing, whether it's like logger info, standard out prints, and so you get that back, and it doesn't actually like hinder your performance at all. It happens asynchronously with your application, and so Go is really powerful, and it actually can use the log library, and it's so simple to log out like any errors or information that you need, and it happens like very fluently. The error handling Go just like lets you do that very expressively, and it's really nice. And yeah, it doesn't have like any overhead and doesn't cost you any execution time at all. So I want to be like a little agnostic about it. So I just want to show you like the cost benefit of any type of serverless application. If you're running Lambda functions on Amazon Web Services, you can use like this free tier up to 1 million requests a month for free, up to like 400,000 gigabytes per second. Let's see, yeah, and so you can run your whole application and never have any issues as long as like, especially if you're not like an enterprise application, you can definitely run your whole application for free through Lambdas or Cloud Functions. It's actually double that. So Google Cloud's free tier is 2 million invocations per month. So you can have your application running in Google Cloud or Amazon Web Services, and you could like probably never pay for it. So it's just like a really nice tool. And with Go, you can do almost anything through a Cloud function or a Lambda function, especially because of like the libraries that are available and the way you can like set up a free API gateway and then hit your Lambda function and then return like any kind of SNS like to any kind of device that you would like. So it's a very accessible tool. You can go home and do it tonight and like build an application for yourself for free and host it for free. So yeah, by the end I'll go through like a really small application I built and I'll show you how quick it is to like put it up and then like have a full flow of an application running. So I just wanted to go like a little bit further into like the Lambda plus Go relationship. So Go is really powerful. It's quick. It builds in seconds. I've never worked in a programming language that's built faster, except maybe Python, but I don't know. For the like tools that it comes with, it's like built for cloud computing, and so it's very expressive, automatic, easy to use. The syntax is clean. You can do more with less code in Go than I've seen. So that's like something about a year and a half ago, we switched the pre-qualification and credit offers API from Java to Go, and it was simpler. Our performance went up by 70%. So it's like a pretty massive jump, and it's like pretty powerful. And when I joined the team I'm on now, I think I learned Go in about a month or so. Yeah, and so it has like a lot of like OOP characteristics, but it has no like type hierarchy. Things just kind of exist, and they don't have to announce their relationship. Error handling is really great in Go. You can return multiple objects from any kind of function you write, and a lot of the standard Go libraries will always return an error with any object they also return. So you can capture these things and return them immediately into your logging. It makes error handling like a breeze. You don't have to worry about it, or like you don't have to like parse different function like returns or anything. You always have like a separate object for that. Yeah, it also has automatic garbage collection. Yeah, and it just makes code easier to write. And so these are all the tools that you would want to automatically happen for you when you're writing cloud functions or like just network functions in the cloud. So yeah, just a little bit of why Go is awesome. Yeah, so I'll read this, but Go's native concurrency is a boon for network applications that live and die on concurrency. It's really built for like networking applications. So yeah, it has distributed functions even when you write it without cloud servicing. So yeah, modern apps are designed to be cloud native and take advantage of like loosely coupled cloud services. So you can like venture into like different cloud services and call them through your Lambda function really easily. It's written expressly for cloud, even the way that, yeah.
Just a question about those OTs. So
Yeah.
when you're on one of these function servers, either Lambda or Google Cloud, are you limited at all in terms of like the number of OTs? Like, is it thread limited? Is it?
It's only limited by, I think, the memory allocation that you give whatever Lambda function that you're running. Other than that, I don't think we've faced any limits, but we haven't pushed it to a limit like that. But that doesn't seem like something that would be a limitation, especially because if it was, I don't think they would have added it as like one of their.
Yeah.
Yeah.
Also, I think Go routines are will be flexed out to single query one way, but that's not true.
Yeah, I didn't know that. But yeah. But yeah, yeah, going back, so you have like combination of safety and speed. So it keeps your applications pretty stable when you don't have to worry as much as like with the error handling and like the speed that Go can process in. It solves a lot of the problems that I stated earlier with the cold start. So when your application serverless functions come up, cold starts for Go are generally faster than other languages. Also, this like little graphic is just like AWS Sam with the Lambda hat and like the Go Gopher. But I also use the Go Gopher throughout this presentation, but they recently changed the logo, in case anyone was wondering. But I like the Gopher. Yeah. So this is like when you have to understand that serverless is not for everybody. We talked about earlier that serverless is not efficient for long-running applications. There's a lot of limitations, like 5 minutes max for Lambda. Another big issue, whether you're using Amazon Web Services and writing Lambdas or you're using Google Cloud and writing Cloud Functions, you can end up in a vendor lock-in. This is a bigger problem for like enterprise things. If you end up writing like a lot of your code and functionality specific to one of these services, you might get locked in case you ever like want to switch services. You will end up rewriting some code, and so that's something that you want to like take into consideration when you choose like your cloud provider, whichever it is. A lot of the functionality and the network that you build won't change. It's just like you will have to rewrite this code. It's not like just switching a server from like AWS EC2 to like a cloud server on Google, because the functionality is written specific for these Lambdas or Google Cloud Functions. So yeah, serverless and microservice in general architectures introduce overhead and different like network calls. So you have to like really understand your mapping of everything. That's a big deal because if you have one application, it's really easy to see like what's calling what and where information is being transferred, and what's slow. Actually, it gets harder to understand where performance might be an issue. So just pay attention to that. And utilize your resources more efficiently. You might have like a function that you're giving too much memory that doesn't need that memory. It can run just as fast with maybe half the memory that you're providing it. Not that that's going to be a big cost for you at all, just because of the way serverless works. But you just really do want to like run it as efficiently as possible. And the same as vice versa. You want to provide enough memory for your Lambda functions. Yeah, and so another part of that is multi-tenancy. Multi-tenancy is it's not an issue that we've run into, especially working at a bank. It might be like it could end up being a problem if we didn't encrypt everything. If you're not familiar, it's just the idea that like Google Cloud or Amazon Web Services are basically running your Lambda functions in virtual containers, and these containers are actually technically on servers for the seconds that they're running, and for those seconds that your function is running, it's technically sharing a server space with other people's code. And so that can be dangerous if you don't protect yourself. So best advice is encrypt everything. Don't keep like mass batches of information being transferred between Lambda functions. Don't transfer MPI data. Like, 'cause a lot of like common sense things, but it's I guess just another thing you have to look into when running any kind of serverless function. So yeah, also it takes some time for a scalable serverless platform to handle like the first request. That's the cold start. So don't expect your application to run at its best at the cold start, and actually just look out for that and like figure out how much your cold start kind of costs you, and figure out like not cost, but like just time. And yeah, understand that writing these functions in serverless platforms will like change your logging systems and all of that. So you have to like really re-understand that and change that in their logic, especially in migrations. Okay, so some first-hand challenges we had, just working through, we had a lot of trouble doing local testing. We were using DynamoDB with AWS, and it's really hard to run like unit tests or ATDD with like a DynamoDB. You have to instantiate a local Dynamo database or any kind of database that you're using, and then we had to figure out a way to actually put data in before a test runs, and then take it out or reset it right after a test runs. So there are understand like test data management, like understanding your data and like ways that you can test it locally, because you definitely want to do that. There's tools that'll let you do that. There is a Java-based DynamoDB like virtual system that you can actually just run right before you run your Go tests or any tests that you run. Error response types. When we were writing cloud functions, we realized that sometimes we might error out a function, but it wouldn't error out because it's still executed. So that's a huge problem, because we're expecting like to get like 400 requests because we maybe sent a bad request somewhere, but the Lambda function would come back with a 200 because it executed correctly. So you have to actually go in and change like the response types for these functions that you write, and control like the statuses that you get back. And there's a difference between your function executing correctly and returning a bad response, and you have to like figure that out. Code duplication is a big one. When you're splitting your architecture, this is more of a migration problem. If you want to migrate your application to a serverless architecture, you're gonna end up like splitting code, and then you have like functions that need helper functions that multiple functions use, but you want to separate their logic. So like it's really weird, right? So what you can do is you can invoke a Lambda that has all of your helper functions, and it's like your utility function, which is like a great way to go about that. You can also just duplicate it, but you have to figure out like how much are you duplicating, how much code are you duplicating. Is it better to create that utility Lambda and then invoke it from everything? Or like you can even shoot up multiple instances of that utility. So it's whatever works for you. You have to figure it out for your application. And yeah, a big one we've been talking about is communication between functions. The whole networking of everything, and everything's listening to everything. You have to make sure that you're not losing anything throughout the whole thing. Packaging dependencies was another simpler problem. There's a lot of dependencies for your applications, and if you're running a Lambda and you're updating one of them, and that one Lambda that you update has new versions of a package than the one that is going to hit it that hasn't been updated, you have to make sure these package dependencies are all synchronized together, because that could cause issues. Okay, so cool. I'm going to go. Oh, yeah. Oh, so right now what we're doing is invoking like lambdas from lambdas. So you have to just make sure on your entire trail of network of like creating like the serverless architecture, you're logging everything. You want to check for errors at every place that you can, and when you have like retry functions, it should stall, like halt before it goes to the next step in your like network, because you don't want one function doing a retry, but it already called the next function. So you want to like stall it. So that's just like making sure you're paying attention to that into your logic when you're writing it. Yeah. Cool. So I just have like a really quick demo. Oh, or do you have a question? Yeah. So you're asking like how to communicate Lambda to Lambda, or? You can do that too, same way, but what I guess the reason to have the lambda is separating logic, but if you're running the same logic into like the sequence, then yeah, you could do step functions. You can do like halts or breaks until whatever you need to do, you can break out, and then when it retries, it runs the next sequence of the step functions. So either way. Yeah. Are you like running a batch job and sending a batch out to like another service, or? Yeah, so your situation is kind of like, I guess what I described earlier, understanding, yeah, you have a long-running application. You can force it to be serverless by like trying to split up your batch job, maybe doing like caching systems, and trying to separate the batch like response to whatever service that you're communicating with over separate lambdas, and then like separating the batch that you're sending over. But generally, that would be like a sign that you might not want to do like a serverless approach. But yeah. You could still take other parts of your application and make them serverless, but that counter defeats the purpose of not having a server, so you don't have to pay for it, because you end up still paying for it. But cool. Yeah, so you can go to that link if you want. I hosted this project, but it was like pretty quick serverless project where I made a Lambda function that actually just hits a weather API, sends you a text every morning of the weather. This was like about like 5-10 lines of code, and it's completely free. And I just used a CloudWatch rule that triggers it on a daily basis, hits the Lambda, and then it sends an SNS to your phone. And so like something this simple, and in Go, you can write to like hit any API, get any kind of notification whenever you want. You can create a CloudWatch rule like I did, where it is a schedule timer when it hits your Lambda, and I just made it hit every day. But you can also do like an API gateway hit, and then like integrate it into a web app that you want to build. So I'll just go into like some of the like specifics of like writing Go functions. Everything in Go, like whether you're consuming or responding to something, like you usually write a struct model. Go is based on models. You need to write your models to consume any APIs, or you want to consume any requests. And so I created this weather request model. I'm just taking the SNS ARN, that's the address of the SNS. The API key for the weather thing that I'm using, I think it's Open Weather Map, and the location where we are. So example, I'm just putting in that. Please don't memorize my API key, but so that's like how it would go in. Location is just zip code, country. And then you would get this response like, good morning, there's currently haze in your area. So this is like all of the functioning, the functionality to like hit the API and publish the SNS. I have a publish SNS function, but it's like just a standard AWS publish function. So all I'm doing is creating a weather function that is like available in Go. The really cool thing about how Go is built is that if anyone has ever wrote a program or application that has hidden API and hosted on GitHub, you can pull their application in. So any project that's like online is treated as a library. And so this is just like someone else wrote like the main architecture to hit the open weather map. I just pulled it in and I wrote like one line to put in my API key, and then I asked it the weather. So that's the really powerful thing about Go. It's a very open source tool. Oh, cool. Okay. Yeah. So this is the published Sns Tool. Really quick. I just wrote like, good morning. There's like the weather in your area. I'll go in. So I'm gonna like pretty much show you how quickly it is to like host Lambda. So this is the function I just showed you. What I'm gonna do is just create a new Lambda, which is just this simple script that I have, where it's just AWS create function with the name, the role that I gave it, because you want to protect your applications, and the zip of my Go project. So I just uploaded it. So here it is. And so what I'm going to do is I'm going to put in like configure test event. So basically it's what you saw earlier. Test weather. And so when I hit this, I'm actually going to get a text to this SNS. So here I'm going to add my phone number. And it's, please don't text me. Oh. But basically, when I hit this Lambda, like it's very quick. Like I should get a text here, cool, and it just says, "Good morning. There's currently broken clouds in your area." So that's just the weather outside. So I don't know what broken clouds mean, but so what the next step of that is creating a CloudWatch rule. So I can go into CloudWatch, very simply create a rule that's a schedule. For this demo, I'll just do every 1 minute, but you can do whatever you want. I add the target. The target is my demo app. I put in the info, which is just a JSON request. I configure the details, test. So in about a minute, I'll get a text, and that text will be the weather. And this will be triggered just on schedule. I don't have to do anything anymore. This is a full functioning application on its own. Serverless, and I'm not paying for it, and I can call it 1 million times a month if I wanted to, and I'll get the weather like every minute if I wanted to. And so, yeah, that's the basic flow. We created like a whole flow. The logs for this application are automatically stored in CloudWatch right now. And so basically, this is a fully functioning application, and it's running in a serverless state. You don't have to worry about paying for any servers or anything. And so, yeah, I think, yeah, there you go. So I just got another text through the CloudWatch rule, like automated. And so, yeah, you can set it up to give you the weather every morning. And that's, yeah, a fully serverless application. So I just want to show you that, how easy it is. I think with the SNS function, it was like maybe 10, 15 lines of code. So, yeah, that's what we did. We created a handler function called the API library, SNS publish, zipped our function up, set up the CloudWatch rule, and added my phone number to SNS, and we had a full function going. And so, yeah, that's it. You can check out the project. Yeah, I'm open to any questions, but I guess we're tight on time. But thank you so much. Yeah.